Hi, welcome to L4M. In this lesson, we will learn heights of a triangle. Okay, what's the height of a triangle? Let's write definition of a height. The perpendicular from a vertex of a triangle to the line containing the opposite side is called. So we are drawing the perpendicular from the vertex to its opposite side. Actually, to the line containing the opposite side is called a height of the triangle. So let's show it on a triangle. Let's say that we have a triangle like that. Let's say triangle A, B, C. Okay. So for example, from vertex A, I'm drawing the perpendicular to the line containing BC. In this triangle, it's obvious that this height will be something like that. Let's say H here. Okay, H1. So you see AH1 is perpendicular to BC, and AH1 is one of the heights, is a height of triangle ABC. In fact, I said height, AH1 is a height, but it's in fact, it's called altitude. So there's a slight difference between height and altitude, but height is used commonly for both of them. So that slight difference is altitude is actually the line segment AH1. The line segment AH1. That's the altitude. And height is the length of this altitude, the length of AH1. Okay, the length of an altitude. For example, AH1. So the length of AH1 is height. The line segment AH1 is altitude, but most of the time we use height for both of these two. So when I say height, you can understand sometimes in the context, you should understand that it's the line segment AH1 itself. Sometimes we will understand that it's the length of the line segment AH1. For both of them, I will use height in the future. So since we have three vertices and for each vertex we have an opposite side, I can draw three heights of it for a triangle. So let's write it. A triangle has three sides. Three heights. And similar to medians and angle bisectors, I will write something for these three heights. All these three heights intersect at one point. All these three heights intersect at one point. Okay, let's again demonstrate what we wrote. Let's say that we have a triangle ABC. Let's say that AH1 is the height from vertex A to the opposite, to the line of the opposite side, BC. Okay, another one from vertex B to the line containing the opposite side, AC. For B, the opposite side is AC. Let's say this is BH2. Okay, and when you draw these two heights, for example, when you draw these two heights, you see that they intersect at one point. But when you draw the third height, it's strange and interesting. Not strange, but interesting, maybe. It's interesting that the third height drawn from the vertex C to the opposite side AB also passes through this point. For example, it does not pass like that. Okay, it should pass through this point again. This is effect again, similar to angular bisectors and medians. It's effect which will be proven at a later time. Okay, let's show it like that. Okay, I will say this is CH3. Okay, so they intersect at one point. Okay, so let's stop here. This is enough. In the next video, we will see how heights intersect in an acute triangle, in a right triangle, in an obtuse triangle. Okay, stay with us, follow us, please subscribe our channel. See you next video. Bye.